So here's a big question for you. Can we really trust an AI with one of the most safety-critical jobs on the entire planet, managing the planes at our busiest airports? We're going to dive right into this because researchers are building a system to do exactly that. And honestly, the way they're proving it's safe, that's where things get really, really interesting.
Think about it. When you're sitting on a plane, just waiting to take off, have you ever actually wondered who makes the call? You know, which strip of pavement you're about to rocket down? It seems like it should be simple, right? But that one decision, it's packed with an unbelievable amount of pressure and complexity.
And that leads us to what air traffic controllers call the runway puzzle. It's this constant, high-stakes game of optimization that has to be played perfectly every single time.
I mean, just look at this list. This gives you a tiny peek into the incredible mental gymnastics a controller is doing at all times. They're not just watching little blips on a screen, they're juggling traffic, calculating wind, watching for storm cells, checking cloud cover, and even thinking about noise rules for people who live nearby.
And this really gets to the core of it. The decision is subjective. It relies on a person's experience, which is amazing, but when you're under that much pressure, mistakes can happen. For a human to compute the absolute best choice in real time with all these things changing at once, well, it's a monumental challenge.
So this is where technology is stepping in. Researchers have been developing a kind of AI co-pilot. Now, it's not designed to replace the human controller, but to help them, to assist them in making the best possible call every single time.
It's called the Runway Configuration Assistance tool, or RCA for short. The easiest way to think about it is like an expert advisor that's crunching all that mind-boggling data to suggest the safest and most efficient runway setup for that exact moment.
Okay, so how in the world do you train an AI for a job where one mistake could be catastrophic? You can't just let it learn by trial and error with real airplanes, right? Of course not. Instead, the RCA uses something called offline reinforcement learning. It basically studies this massive library of historical data, every decision made by expert humans and what happened next, so it learns what an optimal choice looks like without ever touching a live system.
All right, so the AI has done its homework, it's learned the patterns, it seems pretty smart, but that's just not good enough when it comes to our skies. Seems safe, well, that doesn't fly. We need proof.
And this is the million-dollar question, isn't it? How can we be absolutely, positively, mathematically certain that this AI will never, under any circumstances, make a dangerous recommendation? The answer is a process called formal verification. And I love this analogy. It's not like testing a car by taking it for a spin around the block. No, it's more like an engineer analyzing the fundamental blueprints of the engine to prove with mathematical certainty that it's impossible for it to fail. You see, the process is actually pretty straightforward. First, you define the absolute, unbreakable safety rules. Second, you build a complete digital model of the system. And finally, and this is the amazing part, you run a check that explores every single possible state the system could ever get into to mathematically prove it can never, ever break those rules. And for choosing a runway, these golden rules are all about the wind. Based on FAA standards, the AI must never recommend a runway where the tailwind is over 10 knots or the crosswind is over 25 knots. And let's be clear, these are not suggestions. These are hard physical limits tied directly to the safety of the plane itself. So the rules were set. It was time to put the AI through its final exam, a really tough automated stress test to see if it would always stick to those safety standards no matter what. And to make this as real as possible, the tests were simulated using data from 3 of the busiest, most complex airports in the entire country: Charlotte, Denver, and Dallas-Fort Worth. So the exam had 2 big parts. The first was a total worst-case scenario. I like to call it a virtual data hurricane. They just slammed the AI with 100,000 completely random, totally extreme wind conditions. The second part was more of a day in the life. It faced realistic wind patterns based on years of actual weather data from those airports. So, how did the AI do in that virtual data hurricane? Well, in that worst-case, totally random simulation, it made a safe call 70% of the time. Now just hang on to that number for a second.
Now, I know what you're thinking. 70%? I'm not getting on a plane that saves 70% of the time. But remember, this was a deliberate stress test. They were throwing impossible scenarios at it just to find its breaking point. The real question is, how does it do under conditions it would actually face in the real world?
And this is where things get really impressive. In that realistic day-in-the-life simulation, using real historical weather, the AI's safety compliance shot up to 94%. That's a huge, huge difference and way closer to the kind of reliability we'd need.
This chart just makes it crystal clear. Let's just look at the data for Denver Airport. In that crazy, worst-case test, it violated the crosswind rule almost 17% of the time. But in the realistic simulation, look at that drop. The violation rate plummeted to just 3.7%. This proves that while the AI has its limits in theory, when you put it in a real-world environment, it's overwhelmingly safe.
So what does this all mean for the future?
Well, it's about way more than just one cool piece of software. It's really about building a foundation of trust in these new systems.
And that's the big takeaway here. This research isn't just about one tool for airports. It's a powerful demonstration of a blueprint, a method we can use to take these complex AIs and mathematically prove they're safe enough for our most important life-or-death jobs.
You know, the researchers themselves said it best. They said formal verification helps them validate that the AI sticks to these crucial safety criteria. It's like the ultimate audit, giving us a level of confidence that simple testing could never provide.
Which leaves us with a pretty fascinating thought to end on. We now have a path to making AI that is provably safe. So if we can verify an AI is safe enough to help manage our skies, what's next? What other high-stakes jobs in medicine or our power grids or transportation could be next in line? What's the next great puzzle we should ask a provably safe AI to help us solve?